So there has, since the inception of the currently accepted Big Bang cosmological model, been a sense among theists that the idea of creation through something like creation ex nihilo is in what you could say direct contradiction or is mutually exclusive with something like the lambda CDM model or Big Bang cosmology, something that there is vast amounts of empirical evidence for. And really, please know right off the bat that this is not something on the topic of why is there something rather than nothing. This is not an argument for the claim of the Abrahamic God. Rather, this is an argument that the claim of the Abrahamic creatio ex nihilo is in fact not mutually exclusive with Big Bang cosmology. I will not be taking the next step. If I wanted to try to submit evidence for the Abrahamic God, I would not take the next step in invoking the Kalam arguments and the modifications of the Kalam cosmological arguments. That would have to be something else, okay? So I'm not using the Big Bang in any means as a proof towards the claim of God. And I've never really been able to figure out why the Big Bang, even if you're just in the naturalistic paradigm with nothing outside the physical universe, why the Big Bang could even be used as a rebuttal if it's just a natural process, mainly the first natural process, the process for which there were no other before it, then why is it seemingly always used as some type of rebuttal? You know, you may hear people say, we don't need God, we don't need a let there be light moment because instead we have the Big Bang. Now the Big Bang of course doesn't prove an ex nihilo creation, but it also cannot logically be used as a rebuttal. For reasons I will show, it would rather be, with some caveats, it would be the first moment, how could I say it? It would be the physical realization of the ex nihilo account. The currently accepted model for the earliest points of time and space, the Big Bang theory, is really a prediction of our classical field theory of general relativity. The inflationary picture usually is attached alongside nowadays for various reasons. It's accepted by most. Now we don't know how, or even if how is the right question, given that since this is the beginning of space as well as time, the nature of causality is questioned here, so you don't have to work with the traditional definition of causality when you're dealing with the first moment in time. So the nature of causality is questioned, but what we can say is that there was a moment before which there was no other. And this is where the Big Bang occurs. This is the singularity as predicted by general relativity. Now the observable universe is infinitesimally small at the first infinitesimal moment of time. We don't know much about the first instance after the Big Bang in regards to the observable universe because we don't have quantum gravity. We only have, as of right now, that classical field theory. But there is one thing we do know with some degree of certainty, and that is that in the very early universe, in the very hot and dense early universe, in the moments after the Big Bang, or really the moment after the Big Bang, there is a very high energy density within the observable universe, which is still extremely small at this point in time. It's believed that this energy density comes from the inflaton field. We don't really know how that field got there because there's some more stringent assumptions you have to make to get an inflaton field rather than a model with no inflation, but it's believed to come from what's called the inflaton field. And this is where the theory of inflation, of course, comes from. Inflation is a very compelling theory for multiple reasons. It states that in the first few instants of the universe existing, there was a very chaotic and a very rapid period of exponential expansion that saw the universe grow in sizes of about 10 to the 50 in a time of about 10 to the negative 30 seconds. Now this extremely high energy inflaton field, as time progresses, it begins to cool down and calm as the universe expands, of course. And there are what are called primordial seeds in this inflaton field, believed to be quantum fluctuations which create gravitational instabilities that grow and become magnified as time goes on and as the universe expands. We get a reheating epoch as energy from inflation is transferred back into radiation and matter. This keeps energy so high that quarks and gluons actually cannot form up. What's called QCD, quantum chromodynamics, has not gained enough strength yet. We're waiting for the temperatures to come down more right as inflation is ending. This is the strong nuclear force that works on the quarks through the gluons, of course. Gluons must start working to bind quarks together so that traditional matter can really begin to start forming. this eventually does happen, so hadrons can now form. And actually there's, of course, many different processes going on at this time. We get a milestone event in the overall history of the universe. It's called nucleosynthesis. We get 2 different isotopes of hydrogen, deuterium and tritium. We get vast amounts of helium as well as beryllium, and we also get a very small amount of lithium. And anything heavier than beryllium is going to have to wait to be formed in the cores of stars and through supernovas. That's how anything heavier than that, than beryllium, comes about in the universe. You know, those elements that you need for life, carbon, things like that, those things will be formed later in stars. Then about 400,000 years into the existence of the universe, we get the biggest piece of empirical evidence for something like Big Bang cosmology. It's the entity that allows us to directly see the cooling from the very hot and dense Big Bang. It's the cosmic microwave background. We can see it. It's of course been mapped. It's been mapped by a few notable different probes. COBE measured it a while ago, then WMAP, and the most recent one, Planck, the Planck probe. What has happened to bring the CMB about, what happened 400,000 years in, is that temperatures have now dropped to a point to where electrons can now actually bind to free protons. This was not something that could happen before. And this makes atoms, and this forms vast amounts of hydrogen gas. This is known as recombination, and you may alternatively hear it called decoupling. It's just a different word for it. Before this, the electrons were flying freely around, and we call those free electrons. They're just bouncing around, bouncing photons. But after decoupling, the electrons have formed to make atoms. They're collecting together. So now those photons are no longer being scattered by those free electrons because the electrons form up. They're not there anymore. The classic saying here is that the universe becomes transparent. Those photons not being bounced around anymore are now free to move across the universe. So you get a first moment of light, and that's the CMB, and that's what we see. That's what we've mapped and what we've observed. It's that first moment called decoupling. The CMB obviously shows us a time before the stars and galaxies, a time where matter was really just starting to form in the traditional sense. The differing hot and cold, well, not really hot and cold, but the differences in temperature that you see on a CMB map, you'll see them as different colors depending on what data set you look at. But those different colors that you see on the CMB, using the right techniques, analysis of that data can show us differences in things like density, gravitational instabilities, dark matter, things like that in different regions. It's called the CMB temperature anisotropies. Now, early on, I referenced those early instabilities in the inflaton field that came about due to what was believed to be quantum fluctuations. Well, they caused, what's the right word? Oh, it's on top of my head. Non-uniformities. They caused non-uniformities in the early universe to the tune of about 1 in 100,000. And as the universe kept expanding, these 1 in 100,000 instabilities, magnified through inflation, began to clump. They began to create gravitational instabilities. These gravitational instabilities grow because now you have more matter clumping in certain regions than in others. So the regions where there's more matter clumping is going to attract more matter, and the regions where there's less is going to attract less matter. So as these densities grow in certain regions, what comes with it? Well, thermal energy comes with it. These imbalances in density heat up. So now with temperature differences, so it starts with density, which creates gravity, which creates more density, which creates temperature because of friction and things like that, and then you get pressure imbalances. And thus we get a bouncing effect in the plasma of the early universe. So you can visualize this through, as matter clumps in, creating more gravity, which attracts more matter. That friction, as it's collapsing in, that friction causes heat, which then causes pressure, which then causes a repulsive effect. So you get that bouncing effect. It heats up, which creates pressure, pushes it back out, and then gravity slowly brings it back in. So you get a bouncing effect in the plasma of the early universe. Now know that we're still in the plasma phase of the early universe. Traditional hard matter is not present yet. This is still a not solid, not liquid kind of plasma. So if you're getting bounces, if you're getting bouncing effects with certain instabilities in certain regions of the universe, what does that look like? Well, it looks like sound waves, okay? You can imagine throwing a rock into a pool and you get waves out from that instability, when that rock hits the pool, that's exactly what's occurring in the early universe. And actually, these bounces and sound waves are so pronounced in the early universe, and we see them so well in the CMB that they actually have a name. They're called baryon acoustic oscillations. The plasma has the ability to allow waves. They're called sound waves in cosmology. That's just what they call them because it really is a sound wave. Any wave really is a sound wave. Well, guess what? When recombination occurred and when the CMB was created, those sound waves, which were scattering all through the plasma of the early universe, those sound waves were frozen in time when the first photons were released at decoupling, because decoupling was a finite amount of time. That's not obviously not something that goes on forever. The CMB has a finite thickness. So it was a well-defined moment in time. So those waves were frozen in it. It's a snapshot. That's why you hear the CMB called a snapshot of the early universe. And we get a picture of where those sound waves were in the CMB. And in fact, we do see them. In CMB data analysis, as we analyze different data sets, we see them very well. Now, where it gets interesting and where I can really begin to show the robustness of something like the Big Bang cosmological model, things like the Hubble Constant actually come into play. That H0, I talked about that a few months ago. The Hubble Constant characterizes the expansion rate of the universe. It's a proportionality constant that lets us convert between distance and velocity. The Hubble Constant comes into play in CMB data analysis because there is a distance that those sound waves could have traveled before recombination, before the CMB was created. There was a distance that those waves could have traveled, and that distance is called the sound horizon. Now, the sound horizon is directly, and I really mean directly, dependent on certain cosmological parameters and certain density values of our players in the early universe. Things like dark matter, things like that baryon plasma, photons because of thermal pressure, and the Hubble constant in a way. Now, this should be obvious. Denser materials will produce and react to acoustic waves differently than less denser materials. Now, we know most of these densities just through the calculations that come with Big Bang nucleosynthesis, as well as peak structure and peak analysis in the CMB power spectrum. But an offshoot of the sound horizon, which is called the angular diameter distance, it's just, you could say, the sound horizon against its angular size in the sky from us here on Earth. That angular diameter distance is directly and inversely dependent on the Hubble constant, on H0. Now, that angular size of the sound horizon that we here observe, that's known to a very small margin of error. The Planck probe measured it, and we can find it just through analysis of those fluctuations. So there we have it, right? The wonders of the Big Bang cosmological model. The Hubble constant, a major player in the puzzle to fully understanding the universe, in the ongoing struggle to find its absolutely correct value. Depending on which data set you analyze for the CMB, you get different Hubble constant values. So there's something called the Hubble tension, which is where we're trying to really figure out what the Hubble constant truly is. We have a range, but we don't know what the number exactly is. But the Hubble constant is ingrained and directly connected to observations that we make, which themselves are fully predicted and explained by the Big Bang model. For example, the size of those sound horizons from the baryon acoustic oscillations, which are now ingrained in the CMB, we see them, right? Just besides having a theory for something that happened like 13 billion years ago, you know, something that we don't really care about now, the Big Bang model plays an active role currently. It's not just something that's over there that we can't prove or deny. We see it. We actually see its predictions, and they help us make sense of the real world, of the real universe. Another example of seeing Big Bang model or seeing Big Bang predictions in current empirical observations, we can look at large-scale structures. We can look at galaxy distributions across the whole universe. What was it? There was the Sloan Digital Sky Survey, among others, that took a very good snapshot of some of the galaxy distributions in different regions of the universe. But we can look at this large-scale structure to get a read on the sound horizon, because matter distribution actually has a bias towards these sound waves, towards these acoustic oscillations. it clumps in accordance with those sound waves. The galaxies do. So by looking at distributions of galaxies in a certain scale, we see the oscillations, literally see the oscillations, which is a perfect prediction of the Big Bang cosmological model of lambda CDM as well. And remember that the CMB and the objective data that we extract from it is a brute fact. It's there, we can see it, and it's causally connected with the beginning of the universe. Since it is a brute fact, any cosmological theory or model we propose has to align with the data. Well, guess what? What's the biggest theory that aligns perfectly, or not fully perfectly, but for vast majorities of cases that you're looking at, what theory aligns perfectly with CMB data? It's the Big Bang theory, as well as the lambda CDM model. Now, earlier processes that came before recombination, nucleosynthesis, as well as other processes, have predictions for certain ratios between peaks, which are actually observed within a margin, because there's always a margin of error, but are observed in actual CMB peak structure, in what we actually see. And overall, this is absolute slam dunk evidence for something like the Big Bang cosmological model. All right, so let's look at the philosophy or reasoning behind saying that the standard cosmological model is not logically refuted by the creation account given by the author of Genesis. And unfortunately, right off the bat, there's really a major problem for this, and that is that finding an intersection between these two paradigms is actually very close to impossible. These two different worldviews, naturalist versus a theist perspective, are actually built off of opposing premises. In other words, and this is very tricky and wordy, the creationist, for the task of evaluating something like the creation account, the ex nihilo account, the theist starts with the premise that God is already real. Remember, this is not a proof for God. We're not using the kalam or anything like that. The creationist has already established through other means, outside of data observations, outside of anything else, the premise that God is real, and then is looking to see if that narrative is refuted by any empirical data, if that makes sense. Well, that premise is actually contradictory to the whole modus operandi of the naturalist worldview. You famously can't find God in empirical data. Everyone knows this. But the naturalist worldview is one where only concrete data and observations are celebrated. Because of this difference, both camps can actually accuse the other camp of illogical reasoning because the foundations don't even translate. But this is not false equivalence. I'm not making a statement that one or the other is equivalent in any means or anything like that. I'm neutrally saying that there's two different worldviews with different premises. They both have an account for the beginning of time, for that first moment of time. Could the theistic account, with me as a neutral observer, could the theistic account and the naturalistic account be referring to the same truth of a beginning, of a event that brings the universe into existence? Could they both be referring to that in their own paradigm with different premises? And we're viewing both of these premises as an observer, but we're accepting that with the theistic account, in order to grasp, in order to see if there is a truth that relates to the beginning of the universe in the theistic account, we have to accept those premises in experiment. We have to accept God in experiment to see if, in the paradigm where God is real, if it's referring to the truth of a beginning to the universe. Now, I really do think that in order to see if the biblical account matches up with the naturalistic account in any way, you have to actually see it from a modified neutral perspective, where God is not proven real or false, but is rather accepted in experiment, like I just said. Now, a better way to put it would be to say, if we were to enter into this space in experiment and grant God and his reported actions and intentions, would it be reasonable to then say that Big Bang cosmology could be the physical manifestation of the creation narrative, or at least say that it wouldn't be refuted, the creation narrative wouldn't be refuted by modern cosmology? Now, there's a few major points I want to mention, but my argument is as follows. The Big Bang cosmological model and the biblical creation account are not mutually exclusive. Okay, so that's my argument. Now, I will provide three different sub-points, you could say, which would comprise the overall argument. Compromise. Now, I will provide three different sub-points, which will comprise the overall argument. It was four, but I had to cut one after I was able to refute it. The remaining three arguments are, number one, the can't miss it, which deals in timescales and a metaphorical space. Number two is an anthropocentric account, which is time dependent. And then number three is real physical operations, which talks about the anthropomorphized God. So for this first argument, the can't miss it argument, when it comes to seeking compatibilities of the creation account with Big Bang cosmology, there's a problem right off the bat, which is that there are many different groups of theists in America and around the world, but in America, which subscribe to a literal, for lack of a better word, literal interpretation of certain physical actions, which may or may not leave them missing out on some higher level lesson that you can't extract from a literalist physical interpretation. But it would only be the right course of action, in my opinion, to forego the literal interpretation if the author is actively implying that it should be done. When someone like me tries to navigate the cosmological model with the creation account, I may receive pushback from these people who are more inclined to take that literal interpretation. Mainly, if I were to tell them about the CMB created 400,000 years after the Big Bang, there's no way they're even going to entertain that data or even care about empirical observations at all, because they don't believe in the timeline. They don't really believe that light has, taken 1 billion years from that galaxy cluster to reach us here on Earth, because these certain literalist groups still subscribe to the 9,000-year-old universe belief system, the paradigm. They still believe that the universe is, some say 7, some say 9,000 years old. And in regards to saying something like the Andromeda Galaxy is, 2.5 million light years away, they think that that's some sort of trickery, almost trickery by God. It's perceived to directly challenge their paradigm. You can show them everything from parallax to redshift to Cepheid variables, anything, and they're not going to even entertain that data. So then the question is, how do we bring these people on board? Is it even reasonable to request that they come on board? Is this even a sensible thing to ask? Well, there is a way to do this. It's the way to do this, to get these people out of the 9,000-year-old paradigm. If we can show with a very high degree of reason that a metaphorical space is actively implied in the book of Genesis by the author, and there's a major logical outpost, there's multiple really, but there's a major logical outpost which seems to show this, then we may actually be able to make some nice progress. Now, what you may or may not know is that in the book of Genesis, there are actually two different creation accounts given, and those creation accounts actually overlap on one specific day. Now, the first one, it's chapter 1, it's verse 1, it's in the beginning, it's that one. It goes all the way to the resting of God on day 7, and that account ends at Genesis 2, verse 3, with God blessing the 7th day and then resting from all the work that he had done. But the second creation account picks up on verse 4, literally the next verse. It goes back and focuses on the last day where God is making humans. And we know that these are separate accounts, because in the first account, creation ends on the 6th day, and then there's the 7th day of rest. But in this second account, it goes back, so it's a separate account. Now, if we compare these two creation accounts, which are right next to each other, we find something interesting almost immediately. I want you to look at the order of some very specific events that occur in both of these accounts. In the first account, we get water on Earth on the 2nd day, we get plants and foliage on the 3rd day, and then the sun, moon, and stars on the 4th day. Now, with this in mind, let's immediately jump to the second account. Let's cover just a few lines of distance, literally just a few lines of distance. We're talking way less than half a page, and look at the order given in this account. In the second account, we still get water on the earth first, but then what is the next event? The creation of man. Notice how it says explicitly, as clearly as it could be in verse 5, "Now no shrub has yet appeared on the earth, and no plant has yet sprung up. For the Lord God has not sent rain on the earth, and there was no one to work the ground." Then right after in verse 7, "Then the Lord God formed a man from the dust of the ground," and on from there. It's not until the next verse, verse 8, that we actually get the plants. With the mention of the Garden of Eden. It specifically says only after man was created did the plants form. So in this first account, it's explicitly water, then later plants, then later humans. But here in this second account, just a few sentences later, again we're talking half a page, it's explicitly water, then humans, then plants. If these two accounts are describing the same creation event, which they are, then the lead up to day 6 and then day 6 in both accounts must be compatible. But there are obvious differences. Now you would think this to be a problem, right? And on the surface it is. And by the way, there's another big logical inconsistency in the first account where the sun is created on the 4th day, but the sun defines a day. So why is the account talking in terms of days when there was no sun until the 4th? You know, you may ask, how could the author miss these, contradictions, these inconsistencies? How do these contradictions, which are right next to each other, literally on the same page, allow us footing to say that Big Bang cosmology may not be able to refute something like creation ex nihilo? Well, this is why I have called this first argument of mine, argument number 1, the can't miss it argument. This argument hinges on the assertion that, in fact, there is actually no way Moses, the believed author of Genesis, could have missed these inconsistencies. Given that the author was invested and actually did believe in what he was writing, you don't have to believe it, you just have to believe that he believed it, which he very most likely did. If we can accept or give credence to the idea that these glaring contradictions, just a few lines apart, would have been found if it had actually been challenging to what the author was trying to convey to his audience at this time, then guess what? It may have actually never been about the timeline of events in the first place. It may have never been about the believed temporally accurate timeline of natural events. That's a better way to put it. Now, someone may try to get around this, but this contradiction, which is a truth, it is a truth that there is a contradiction in the book of Genesis. It exists independent of any observer. Under our language and grammar paradigms, this is a contradiction independent of me. I'm not projecting a contradiction onto this passage so that I can get to a metaphorical space. It's actively being implied independent of me. It is a fact that there is a contradiction between these two accounts that's independent of me. I fully believe that these inconsistencies and contradictions would have been found and would have been corrected if it was actually challenging to what the author was trying to get across to his audience. It was included anyways, which is a pure indication that literal bottom-level accuracy in the believed timeline of physical events was not the goal of the creation account, either the first or the second. Rather, it seems as though it was about the higher-level lessons that the people of Israel would take away from this passage in regards to who God is, his plans for the evolution of the earth, things like God's intentions for animals on the earth, for plants, things like that. While accuracy in the physical manifestations and temporal scales of God's actions was never really the point. It seems as though it was all about those higher level lessons. I'm not arguing that it isn't physically reflective of reality. I'm arguing that the author of Genesis, it's different. It's more subtle than what you may think. I'm arguing that the author of Genesis would not have put in these obvious contradictions where they're literally right next to each other. He would not have put them in if it was actually about being reflective of the believed reality in terms of the physical events and a temporally accurate timeline, or an accurate timeline of events. So if we accept that contradiction, then the question is, well, am I projecting a metaphorical space where there really isn't one? Well, I don't think so. I'm just making a conclusion given what we know about the interactions of the author and this passage and the author's intentions for what he wanted the audience to learn. We know he was deeply invested in the account he was writing, And we know, of course, he believed in God. You don't even have to believe in God. You just have to, like I said, believe that he believed in God. We, of course, know that really plants didn't come before the sun. Other stars were alive in the universe billions of years before the earth came about. This is not reflected in the creation account, but I propose that it was never the point of the creation narrative. The author's action, or really his lack of action, seems to be actively implying a metaphorical space. This is one of the main reasons why I believe Big Bang cosmology can't refute something like creation ex nihilo, because the creation account is not even trying to be something like Big Bang cosmology. So now we can bring those people who didn't believe in the in the cosmological paradigm, the Big Bang model, we can bring those people on board now, because now there's nothing stopping them from the empirical observations. We've shown that this seems to be a metaphorical space, so you don't have to push back because you're taking the literal interpretation. You can let go of the literal interpretation now. Now here's one more rebuttal. You may be led to challenge the legitimacy of the author or the legitimacy of the text, given that these contradictions are included. But as you have seen, this argument hinges on the assumption, and there's no way to prove it, but if it's the case, then this would follow, that this was intentional, because we see both how close and how damaging these contradictions are to the creation narrative. Now, we don't 100% know the intentions of the author, but if he included those contradictions with the assumed premise that they were either intentionally left in or were glanced over and didn't really matter, then we have reason to say that it was never really about that in the first place, a metaphorical space. All right. Now, argument number 2, which is the anthropocentric argument. Since I am accepting that metaphorical space and interpretation of the creation account, a skeptic may say something like, so what you're saying is that parts of the Bible should not be taken literally, or has to pass through the filter of a conscious agent and is not whole on its own. So doesn't this contradict the verse that all scripture is God-breathed and inspired by God? That's 2 Timothy 3:16 through 17. And this is actually a good point. However, I don't think it holds. I can only say that the Bible is inaccurate in the creation account scenario if I believed it was trying to give that physically accurate, unanthropocentric account of the beginning of the universe. I don't believe this to be the case. Now, obviously, one of the biggest messages of the Bible, or lessons of the Bible, is that, in a sense, now not physically, obviously not the Copernican principle, but in a different sense, the universe is actually anthropocentric. That conscious agents here on this earth and probably elsewhere in the universe are actually the prized possession of God. We by design hold a higher status than any planet or star or galaxy or anything like that. The narrative says that the sun and the moon and all of their glory were actually created so that we could keep track of time. We as conscious agents can actually experience. We were given dominion as we were the last thing created by God. Now, obviously, the creation narrative was firstly created for the audience, for the primary audience that would receive it, for the first generation. It has no chance of spreading if it is not first relatable and understandable to people in the receiving group. You know, you can't tell the author of Genesis, Moses, who it was believed to be, you can't tell the author of Genesis about something like Big Bang nucleosynthesis or something like, you know, recombination creating the CMB. You have to give it in terms that the primary generation at that time can grasp and convey to others if you want your agenda to spread. The problem is that there are people who think that this is the only function of the creation account, and so they blast it as being scientifically inaccurate. If you're attacking Genesis because you don't see the cosmological models in the creation accounts, I really do think you may be looking at this wrong. One of the foundations of the believed relationship between God and humans is that the human being, the agent made in the image of God, is valued more than the entire expanse of the inanimate cosmos. So any account given to us is, by design, going to be anthropocentric. Now, this third argument on real physical operations, it focuses on the meaning of interactions between the proposed God in the physical world, specifically at the Big Bang. Hebrews 11:3 really encapsulates what I'm trying to convey. It says, "By faith we understand that the universe was created by the word of God, so that what is seen was not made out of things that are visible." Now, it is obvious, even to those who don't believe, everyone accepts that the proposed God lives in a higher level space, disconnected from the physical world, but still we would accept that he's able to interact with the physical world on demand. Now, I know everyone at one point or another has heard something similar to this statement right here. There's just no more space for God. We don't need him anymore. We have something like QCD or Big Bang nucleosynthesis or whatever. And you know, these amazing theories and the overwhelming majority of people who study and refine them, who do not believe in God, when they say something like, we don't really need God anymore to explain the physical operations that we see in the universe, guess what? When they say something like that, they're actually right. The scrutinies we use to test the legitimacies of a scientific theory or a scientific claim logically cannot be the same ones we use to test the legitimacies of a religious claim. You'll sometimes hear this idea being put as non-overlapping magisteria. They're different domains, so you would have science and then a theistic claim. You have science on one side and then a theistic claim on the other. You don't on the inside, and I have to be careful how I word this, you don't need something like religion to explain the physical operations we observe in the universe. And that would be by design of God. You know, something like the fluctuations in the CMB that can just be kicked back the temporal chain of events. The physical world would be completely consistent with a religious belief, but you cannot prove a religious belief from the physical world. The physical world is proposed to emerge out of and be separate from the religious reality. God is proposed to have created the universe. The universe comes from God, but the universe is not God because he's by definition outside of it. That's why, in a way, common ground can be found. It's not really common ground with this argument. Rather, like I said, the best way to put it would be that they're not mutually exclusive. These different domains, you can, in a space, have both of them coexist at the same time and they wouldn't be excluding each other. I really do think that a big problem for the church in the last, say, 1,000 years is that we have anthropomorphized God maybe a little too much. And this has caused us to discount the fact that God could perform certain interactions through natural processes. Instead, we've adopted the view, since we've adopted the anthropomorphized God, perhaps a little too much, we've adopted the view, or we have the image in our head that he would rather have to be on the earth, standing on the earth in some form, waving his hand or waving a wand and performing these interactions. Now, he could be on the earth and wave his hand to perform interactions if he desires, but that's not my base case, you could say. He's not strictly human in any sense, right? It's reported that in the Bible, it said that that Jesus had to take on the human flesh when he came to earth. He had to take on the physical human form. So why would you have to take on the human form if you were already the human form, right? Any imagery you have in your head of God where you're projecting human qualities onto this image and then confining him based off of that human image, that has to be discarded, I think. As an omnipresent being who is defined to be everywhere, ask yourself, is he strictly human? Is he literally human? Obviously the answer is no. So then those human attributes that we ascribe to him, a lot of that has to be put to the side, I think. And we were told that we were made in his image. Well, yes, but the consensus nowadays among a lot of theists is that that probably didn't refer to the physical image of God. That probably referred to some topic around consciousness and conscious agents rather than literally physically being made in the image of God. But by itself, the anthropomorphization of God is not necessarily a bad thing. It helps us to grasp the idea of God, and by the way, he seeks that personal relationship with us. But it can be somewhat of a problem when you start discounting certain things about how God would interact with the physical universe, because rather you're too busy ascribing these physical attributes to him. You may say something like, well, God wouldn't do it this way because God's human, so he would be on the earth waving his hand instead of just performing this action through natural processes, something like the Big Bang. I don't believe him to do this because I could never imagine a human doing that. That's where it gets to be a problem. You're projecting human qualities onto him and discounting qualities about him which don't seem to be human.